what's up folks, and welcome back to another 3D Hangout. You got Noed and Pedro here. I'm Noed, designer here at Adafruit, and joining me every week is Pedro.
Hello everybody, I'm Pedro, Creative Tech here at Adafruit, and every week we come to share 3D printed projects featuring electronics from Adafruit.
That's right, this is a show where we combine 3D printing and DIY electronics to make inspirational projects for you folks. Welcome everybody to the show. We do have a coupon code. We're streaming an hour earlier, and this is why. Coupon code is final hour. So if you have, if you would like to order anything in the Adafruit Shout, you have about an hour left to do so until shipping stuff starts shipping. So our cutoff is at 11 a.m. Eastern time, which is an hour from now, about an hour. So we got a coupon code for you. This will get you 10% off your order. It works on everything in the Adafruit Shop except for the gift certificates and subscriptions to Adabox, which are going to be postponed, but they're still happening.
That's right. If you guys have not seen the announcement from the live stream last night, definitely check that out. PT and Lamar go over all of the things going on during the pandemic around with COVID-19. Definitely check that out. We are going to cease shipping at 11 a.m. today. Doesn't mean that we're closed. Just means that shipping and a lot of the other stuff around New York is going to be shutting down around that time. So we're still going to be online. We're still going to be doing live shows. And it's all because of your guys' support. I want to thank everybody for hanging out with us every week on all of our shows. It definitely made the difference in being able to continue to operate in this fashion. So definitely check out the video to get a little bit more in-depth on all the goings on. We're also going to get paid. We're all still operating. It's just that shipping is going to be halted until the situation around New York clears up a little bit and they lift some of the shipping and things like that around the area. So definitely tune in for that. Check out the blog post for additional info. But we're still here. We're still having a show and tell later tonight. Show and tell is still going on. We're actually going to do an hour-long show and tell, so definitely sign up for that one. You can, get a little bit of, getting your mind off of what's going on, having your kids home and all that, show off all the projects and things that are going on. Definitely want to check that out.
Yeah.
And tune in tonight. I think John Park is still doing his show right after that on tomorrow.
Yeah, we're hanging out in the Discord server, so if you guys want to say hello, have any questions or anything, we'll be there for the most of the day. We're in the live broadcast chat room. So this is 24/7. You guys can check out all the different channels. And thank you to everybody hanging out. We're hanging out as well.
Giving shout outs to everybody in the chat. Sorry, couldn't, for whatever reason, YouTube or Facebook decided to update their live broadcast dashboard on the
It just doesn't want to go for
wrong
some
day
reason.
to do that, Facebook. So shout out to everybody in the YouTube. Over here we got MK Me Lab, got James Dunham, got Jeff in the Discord.
Jeff Epler, hello.
Got Yanni and Kinger North, Dan Mitchell. Everybody hanging out in the chats. Good morning, everybody.
Yeah. Well, we're still going through the morning routine. Do we want to show the what's Jeff?
Definitely check out the Discord. You can see
all
of the cool things that are being worked on.
A Gunk Droid says hi. Hello, Gunk Droid.
It's so awesome.
That's awesome. I love the scale of it. It's like spot on. That's great.
Let's continue on with the housekeeping stuff. We still have the
freebies are still going on as the supplies last. So if you go to Adafruit/free, Adafruit.com/free, you can see all the different tiers. For orders that are $99 or more, you get a free Perma Proto. For orders that are $200 or more, you get the Perma Proto plus UPS ground shipping, continental US only. Orders that are $299 or more, you get the shipping, you get the Perma Proto and Circuit Playground Express. There we go. Yay, those are still happening. That's good. Same day delivery is still an option, I believe, only in New York City for about an hour or so left, but that's still happening. Let's see what other to-do stuff. CircuitPython meeting did happen this week. It happens normally on a Monday at 2 p.m. Eastern time. It's about an hour and a half long. This is a great chance for the community and the core devs to get together and find out what everybody's working on, what they want to work on. Lots of different things going on there, so check it out. It's every Monday on the Discord server. It's streamed live, not streamed live, but it happens, it's recorded sort of live in the Discord channel, so check that out. You can get an invite to Discord by using the URL discord.gg/Adafruit or adafru.it/discord. Any of those links will work fine. And I'm hanging out there right now in the Discord channel, the live broadcast channel. That's where we're hanging out. We're in the live broadcast chat room. But if you want to join in the CircuitPython meeting, it's normally done in the CircuitPython topic here channel, CircuitPython. That's where it happens, so check it out. Okay, back over to live broadcast. All right.
All right, we still have projects going on, so let's go ahead and jump into this week's super awesome giant project.
Yeah, it's a pretty
will
big
definitely
build.
keep you busy during the entire epidemic. So
Yeah.
go ahead and check out the MX guitar.
Yeah, I will do just kind of a quick demo. So we've been working on this this project for a little bit now, and it's basically a MIDI controller. It's in the shape of a guitar, and it's using MIDI. Right now, I just have GarageBand loaded. Hey, Rufio, you're in the show. You're in the shot. How you doing, buddy? So I'll just kind of do a demo. It plays a lot like a guitar, so you can kind of play it like a guitar. It's got a whammy bar. It's got accelerometer as well for doing the things with accelerometer. So that's really fun. Let me play with the strum mode real quick. So I'll load a different instrument. And again, it's a MIDI controller, so it will work with any of your kind of standard DAWs. So like GarageBand, Ableton Live, Reason, FL Studio, those sort of things. Yeah, so this mode right now is just kind of like tap mode. So you can just kind of play. So these are Cherry MX switches, which are normally used in gaming keyboards. And they're the speed silvers, so they're really quiet. And they have like a low actuation point, so they're really good for, I think, playing kind of notes and things. But back to the demo where we're strumming. We have these panel-mounted switches that allow you to switch between the different modes. So strumming mode, let me see if I can get that. All right, so strumming mode, when you hit these keys, you can use the pick to kind of strum. So you can get this unique kind of playing style. You can kind of flick it like a pick too. Let's switch back to while I'm holding down the chord. That's a lot of fun. These potentiometers here allow you to kind of adjust the velocity and the modulation, whether you're in accelerometer mode or not. So when you're not in accelerometer mode, you can use the potentiometer to adjust the modulation. Let me find a good synth that has the modulation. So that's about velocity. And you can adjust the values in the code if you want to have different orientations. There you go. In the head of the guitar, I have black LED acrylic with a strip of neopixels on the inside. There's also a feather that's hidden inside here, underneath the keys here. And I also have a built-in on and off switch there. This is a real whammy bar, like an actual one for electric guitars, so that fits right here in the modulation wheel. The modulation wheel has a pretty interesting little mechanism. It has an extension spring on the inside that allows it to kind of go back to the center, so it's always centered. It behaves a lot like a pitch bending wheel that you find in sort of your standard MIDI controllers. Let's see what else. To kind of change up the notes, we have this 8-way rotary selector switch So you have 8 different sets of notes that you can play, or set up not octaves if you want. A lot of fun. Let's see, what other features can I kind of talk about? I'm drawing a blank. The CAD files are released on all the various sites. The code written by Liz Clark from Blitz City DIY is also available on GitHub. So you can get the code on GitHub right now. It's public on the Adafruit's Adafruit Learning System GitHub repo. And that is linked in the description of this YouTube video.
I posted links too.
And Pedro also posted a link to it. And it's all written in CircuitPython using the USB MIDI library. So I hope to make some music during, not the break, but yeah. Cool. I'm gonna put it down now and take a look at the Learn Guide. Ann Barella, who's on the Adafruit remote team, is actually reviewing the guide right now and doing some copy edits and things. So it's simmering it's simmering, I guess, for a little bit, but I'm gonna log into it and see if we can kind of pull out some stuff. Just gonna give you a browse through. Hopefully I can sign in here. Let's see, where's the device? Of course, I got logged out of the Learn system, and we got a nice 2-step auth going on. All right, here we are. Sweet.
So the guide
There's
will be
the
launched
guide.
later tonight.
I think
So
later tonight or tomorrow, we'll see.
Guide
Yeah.
is massive, lots of pages, but let's go ahead and try to go
Go through it, yeah.
through it a little bit.
Yeah, sure. So yeah, this is a collab project with Liz Clark. She runs her own YouTube channel called Blitz City DIY. That's sort of her handle as well, so you can find her on Instagram and Twitters at Blitz City DIY.
She is also in the chat, so
Hello,
any
Liz. Good morning.
programming questions, definitely
Yeah, feel free to
ask
ask.
that.
Yeah, so you can see in this hero shot, it's right next to a Guitar Hero controller. Guitar Hero was a game that came out, let's say 2000s-ish, early 2000s-ish, and it's a really awesome looking controller. A lot of folks like it and dig it. So the story goes, like, back in 2013, I wanted to make a MIDI controller, sort of a MIDI fighter-esque box. But instead of kind of going with their traditional box with buttons, I wanted to kind of make a different style of it. So I figured making a guitar would be really fun. So back in 2013, we made
You can go grab it if you want.
Yeah, I think we can. No, you don't have to grab it because I have a Learn Guide right here. So it was this guy over here. And this is kind of what was the original idea. It used the Blue Fruits Easy Connect to make some, like a Bluetooth keyboard, and then we use virtual MIDI to make it into a controller here. So box of buttons. So this time around, we have, where did it go? There it is. This time around we have different buttons. Instead of arcade buttons, we're using Cherry MX switches, which are known for gaming, and there's lots of different styles and variants of them. They can be really clicky, or they can be really silent and speedy, hence the name Speed Silvers. And they're really known in the gaming community. I don't think a lot of musicians have tried using Cherry MX switches for like musical instruments, so this is kind of a fun look into how does that feel. It feels really great. Yeah, so it's a huge inspiration from the Guitar Hero controllers, and they made several different ones for like the Wii, for the Xbox, and for the PlayStation as well, I believe. So lots of different variants there. So what we did is Liz has a couple of them, and I asked her if she would take hers apart, so that we can get a look at how does the strumming mechanism work and how does the whammy bar work. So she took some really nice pictures. If you look at a stream from like 2 or 3 weeks ago, I'm like looking through the teardown photos and showing all the different pieces and bits that make the mechanisms go. So yeah, that's what we did. So you got the whammy bar and the strum. Those are really like the main kind of challenging things that we had to figure out. But they're now in a state where they're definitely reproducible. They can print without any support material, and the assemblies are fairly straightforward, which is nice. And it's using off-the-shelf parts, like the whammy bar. It's a standard whammy bar. The extension spring is sort of a standard spring size that comes in like these kits that we have linked. And the design of the guitar, really, I designed it so that it could fit on sort of your standard build volumes. So that's like your Prusa i3 or an Ender from Creality, or even an Ultimaker. So the build volume is actually listed right here in the front page, 250 by 210 by 200. And they're split in a way where the what do you call it? The seam where they're split kind of goes with the shape of the guitar. It's a flying V is the style of guitar, I guess, the shape of it, and that looks really cool. Shout out to Liz for recommending to make it a flying V guitar. Let's see what else. The black LED acrylic that's in the head of the guitar is sort of an extra add-on. You don't have to do that, but I really like that material, and having NeoPixels in your project is just a fun thing to do. It makes it look really nice as well. So it's the main board, the brains of the project is the Grand Central M4 Express. This is running the SAMD51 chipset, so it runs CircuitPython excellently. It's got some internal SPI flash as well, so you can have all sorts of different audio clips or whatever in there in your storage. It's also got a card reader and just so many IOs. We have about 27 or so inputs, and the reason why we're using the Grand Central is because the Metro, which is like the smaller board, it just does. I think it maxes out at like 22 GPIO. So that's why we chose the Grand Central, because it has all the info that all the GPIO that you would need, plus more. So if we want to add more faders, more pots, more buttons, you definitely can. There's plenty of I/O for more stuff. Yeah, and it's purple. We're using the accelerometer, the LIS3DH, which we've used in quite a few different products and quite a few different projects. And then we got a bunch of different potentiometers, the rotary selector, these little mini switches, micro switches rather, that have the lever. This is what's inside the strumming mechanism, and those levers are what help trigger and actuate the strumming mode. Also using a little perma proto, I kind of cut off one of the power rails pieces. That way I can extend the ground and power pins from the Grand Central. There's only a few of them on there, and since we have quite a few components that need power and ground, this board using a little piece of it helps out. Yeah, so that's why we're using that. Because the board is embedded inside, you don't really have access to the micro USB port for powering and programming, so we have this panel-mounted extension cable that is panel-mounted to the side of the guitar, and it kind of routes through the inside there, and the length is like perfect for the size of the guitar, so that's really cool. These toggle switches are really nice. They got a nice feel to them. They're small, yet not too small, and they work really well here for changing the different modes. And then we have this USB cable that has nice length to it, 2 meters long, and it's just micro USB. Yep, so I have a parts list here that has all the different parts and all the different wires. So because of the scale of all the different parts, I really recommend using JST connectors or any type of connectors really, so that the wiring management and the assembly is more manageable. Also, a 10-wire silicone ribbon cable is used throughout the builds, throughout all the connections almost, which is a really nice wire to work with, in my opinion. Then we have some parts that are not sold from the Adafruit shop, so we're looking at the Cherry MX switches themselves. I found a 10-pack available on Amazon. Again, these are the Speed Silver variant of Cherry MX switches. And these are really nice because they don't make that clicky sound, and they have a low actuation point, which makes them speedy, so that if you're trying to do fast playing, this is the best bet, I think. Yeah, so you can get 10 of them for how many? Like about 12 bucks or so. Yeah, and they're really nice quality switches. They're great. I love them a lot. And let's see what else. We have keycaps as well. You want to get some keycaps for the MX switches. The whammy bar comes in different colors, but they all tend to have the same threaded bar that's sized to fit in your standard electric guitar. Also, these potentiometer knobs, I think these are from SparkFun. These are really nice. If you're ever doing like a musical project, and you want to do like volume or something, these knobs are excellent. Comes with a grub screw, so you can tighten it on your onto whatever knob, and they just look great. They feel great and they look great. So you can pick those up from SparkFun. We also have some other ones. I also found this knob that's also sold by SparkFun. This is like a selector knob. It's really nice. It's got the grub screw as well. And then the extension springs. I found a kit on Amazon. They all tend to have like the same standard sizes, so you can pick up the kit if you don't have any springs, and have them in your arsenal for future projects. When it comes to the hardware, boy, golly, there's a bunch of them. There's quite a few different screws. The majority of them are M3 sized. So I have them all broken down here with the quantities and the lengths. Also some hex nuts and some standoffs. And they're kind of separated in, they're segmented here so you know where they're going, like the guitar neck, the bottom half of the guitar, and the top half of the guitar. Also, we have some M25 screws that we have a kit, like a black nylon kit that we stock in the Adafruit shop. And also, it's worth getting a kit of M3 standoffs, which are sold from Amazon, so you can get those up. I think that's most of the parts that we're using. Yeah, I think I forgot to link the black LED acrylic, but I do have that linked in our heart project that we did. Again, we're still working on it, so I'll need to make a mental note of that and add that in the black LED acrylic. But you could print it in some translucent filament and kind of make your own diffuser cover, because the STL file is available. Oh. Circuit diagram, yeah, lots of wired connections, right? If you want to make your own wire diagrams, we do have a library of Adafruit parts that you could use. Yeah, this one's actually using a little bit of a clever workaround. It's an Arduino Mega, but like a JPEG image or the sorts that's layered on top of here, so that we have that nice image of the right board. All the wired connections are broken out here for accessibility purposes. So it's a good list here of all the things. And then for doing the NeoPixels, it's a separate system, really, a separate board. It's the Feather M4 Express. And that way, we don't have to do too much complex stuff with timing and stuff with the NeoPixels and the code that's running the MIDI stuff. So that's why we broke it out into its own circuit. Pretty standard circuit. You got your 3 connections for the NeoPixel, and then enable and ground to turn the 3-volt regulator on and off. So you can charge the battery while the circuit's off. Yeah, so that works really well. I have a 500 milliamp LiPo battery that's hidden inside the neck of the guitar as well, which we'll look at as we kind of scroll through everything. So here are the parts for that. Yeah, it's again, it's more of an optional thing if folks want to add some neopixels to it, this is a way to do it. Yeah. All right, setting up CircuitPython on the Grand Central. We have a nice link here to the page, standalone page that kind of walks you through that. Or you could just go to circuitpython.org and select the Grand Central and download the latest beta, or not even the beta. It's not RC. What is it? It's stable. It's a stable release. You can get CircuitPython 5.0 stable release, and it's been tested on the earlier betas, but it also works on the stable release as well. A couple libraries that you'll need: the LIS3DH library, the bus device library, Adafruit MIDI, and Simple I/O. So we just kind of walk you through that. And the code, again, by Liz Clark, you can grab it, do a pull request if you'd like, modify it. It's heavily commented and very customizable. So if you want to create your own sets of notes, you can do that here. And we'll walk through the guide walkthrough. That's right over here, the code walkthrough. Great job by Liz, breaking everything out. So it's a nice deep dive into the setup, all the libraries, and some visual images of seeing where all the pots and where they connected to and what pin is where. So this walks you through that very well. And they're all just adjustable. You can customize which pin out you want. If you have a different board or something, you can do that. See what are some interesting bits. Yep, note arrays. It's written in a way where you can just type out the note as opposed to like having to remember what the note number is. So that's really nice. Yep, and then there's some debug stuff, so you can see what notes are being pressed when you have it connected to the Mu editor and you're looking through the serial console, so you can kind of get an idea of what are the notes you're playing. Yeah, so definitely take a look at that if you are interested. And it walks through all the different modes and stuff too. Yeah, it's pretty thorough. Check it out. The CAD files are available to download. I've just published them on all the different sites. You can also get it directly from Autodesk's website if you have a file format that you like. There's a little drop down once you click on this link to download the various formats. But I have a parts list of all the parts and a photo of them grouped up. They're really split into the three. The main body of the guitar is split up into its own section. And then you have just the parts that create the strumming mechanism. And then just the parts that create the whammy bar mechanism. Again, I split them in a way and orient them on the bed so that they fit and that they don't require any supports. So that is really nice. If you are working on your own 3D models and you are looking to find some 3D models of Adafruit parts, we have a GitHub repo. You can check it out. I have it linked here, and I try to link it in every one of our guides. You can also search for it on GitHub. It's github.com/Adafruit/Adafruit CAD parts. So just search for CAD parts Adafruit if you want to find that. But I tend to have it linked in all the different places. You can create a pull request too if you want to, or create an issue if you want to request some parts. Shout out to Daniel, who did a pull request and added some parts. Yeah, that's very helpful. So the way they work is they all have the PIDs, which is the product IDs, in front of the name, followed by the name. So if you wanted a Grand Central, you could just search for Grand Central. And I have them in the Fusion 360 file format, a step file format, which is kind of a standard solid modeling format, STL, of course, and a JPEG/GIF if we have that, so you can get an idea of what it looks like. There, like that one. They tend to have all the components on it as well. Some of them even have headers. And those are all modifiable. Cool. I walked through kind of slicing the parts. One of the tricks we found is like when you have a really long yet narrow part, you can actually rotate it about 45 to 50 degrees on your bed and actually get that extra length because it's diagonally. So like for example on the Ultimaker 3, if we were to try to slice and print the part, it won't fit because of the dual extruder and things. So if we just orient it 45 degrees, you can get that printed. You can also fit multiple parts on the bed. Here I'm fitting 2 of the wings on the Ultimaker, and that way I can print 2 of the parts at the same time. Since it has such a large surface area, getting a really nice first layer is pretty critical. So do all the things. A brim can be helpful if you are getting warped corners. A brim will help keep your part down so it doesn't curl up.
By doing all the things, you mean level?
Yeah, level the bed.
Each corner.
Make sure you wipe it down with a little bit of alcohol, the bed, whether you're using glass or PEI, all that stuff.
One of the things I found is very useful, instead of using a piece of paper, because it can start to warp once you heat up your bed, is this little gauge tool. It's a 0.2 millimeter gauge tool. So all it is has the thickness of 1.2, and you can level each corner of your bed, either manually or with whatever probe you have to ensure that you are getting each corner nice and level, and that's going to help a lot. You'll save a lot of headache when printing huge parts, because there is a difference between printing something that's 100 millimeters to something that's like 200 millimeters. You are going to get that deviation on each one of the corners, so definitely pick up one of these gauges to make sure that you're nice and level.
Yeah.
Nice little tip there.
Cool. Okay, so that's pretty much the 3D printing parts. No supports, oriented to print as is, and all the files are open. Source files included. Cool. So when it comes to the assembly, I really feel like following it in this linear order makes a lot of sense. So that's kind of how we did it. So what I think is the best thing to do first, once all the parts are done, let's start fastening some of the parts together. So the neck and the head get fastened together with these 2 screws and hex nuts. So I have these photos that show you how to get in there. I like using these needle nose pliers to kind of get a hold of those hex nuts, because there's not a way to make it a cap nut. Yeah, so I'm just using needle nose pliers. There's a hole there. The hole in the center there am I on the right screen? Yeah. It allows you to kind of get access to the feather that will eventually be in the neck, so that you can recharge and reprogram if you need to. So that's why there's a hole there. Yeah, so that's how those two parts are fastened together. All right, the head cover, black LED acrylic. I don't really walk through milling it, because it could be laser cut, could be CNC'd, or you could just 3D print it using translucent material. But this stuff's really nice. I ended up hot gluing it to the snap fit cover, because otherwise it would kind of pop out when you snap fit the cover onto the head. So that's what I did there. Yeah, not much else to that one. The strum assembly is kind of like the first mechanism that I want to build. So I have the screws listed here, and you want to install them in this order. Get those joints on there on top of the base that kind of holds the strum in the center. To avoid support material, I broke out these little nubs that go on the side. They're going to kind of create the pivot point for the strum. So those are just press fitted through the little holes on the inside. It's a bit of a hollow geometry, so you can stick that in there and hot glue it in place, which is what I did. And that way you have these little nubs that come out. Otherwise you would have had to print it with support material if you had them sticking out like that. There's a little bit of a flex to the base of the base. There's a bit of a flex to the base of the strum. That way you can kind of flex it open and get those nubs inside the little hinges. And yeah, that's just kind of showing how to get the pick inside the strum hinges. Yeah, I gotta work on my labels. So a word about these micro switches. These are ones that I got off Amazon, and they kind of have like a hard press to them. They require a little bit extra force than the ones that we actually carry in the Adafruit shop. They're green. They have like a green colored housing. And that kind of indicates how they're different, right? So I would not recommend these. I don't have these linked, these micro switches. I have ours linked. They're out of stock at the moment, but They are different. They have a better, the green ones, they have a better, they have less force required, which I think makes it easier to strum and play with. That's all I'm saying. You're going to need some longer screws to attach these to these little brackets here. But these micro switches, they tend to have the same mounting hole setup. So even though they have a different like force actuation, they do have kind of your standard sized mounting holes, which is great because I was able to, use these even though they're not my preferred ones. Let's see, I walked through wiring up the JST connectors. We actually have a JST connector kit now that I should definitely link because it's really helpful to have that as opposed to having to use or find or purchase pre-made JST cables. Yeah, so I walked through wiring those switches. Once those are wired, we can start assembling all the various pieces into the body of the guitar, which gets me, I think I skipped the body. Yeah, I skipped the body for, oh gosh. Yeah, but once you have the body assembled, which I skipped the page, I do have a page in that, you can start mounting the switches in the right spots and then fitting the pick in where it needs to be so that it can actuate the micro switches. Yeah. Man, why did I skip that? It was an accident. But yeah, the next thing after the head, you want to assemble the body, the top and the top half and the bottom half. So this is how they're split. You get a really good idea of how they're split there. There's these built-in tabs to the edges there that have mounting holes, and the M3 screws just kind of fit through. Put some hex nuts on the thread of the screw, and then just fasten them tightly using a needle nose plier, I think. And you want to do the same for the top half as well. And the neck is attached with these three hex nuts and screws as well. They kind of fit in nicely, have a nice tight tolerance, but not too tight. That way you can get the screw inside there and also the hex nuts, and that's what it looks like. Yeah, so the top half has the neck and the head of the guitar mounted to it. It's kind of like creates like a one-piece setup that snap fits onto the bottom half. Yeah, so they snap fit together, the top and the bottom half. Okay, then we do the strum, and then we can do the whammy. The whammy bar, I split it into several pieces so that I can avoid support material. Really, this shows you all the little geometry bits that would be prone to use support material. But splitting it in this way, I think, works out really well because it makes it so that it's the strongest, and yeah, it works out really well. You do have to use some super glue to kind of attach these pieces together, but I walk you through that. Yeah. Then I'm using this little extension spring that will keep the whammy bar centered in the center so that when you go left or right, it'll always snap back to the center. And this is pretty much exactly how the whammy bar mechanism works in the Guitar Hero controllers. There you have very similar kind of little ring holders that hold the spring. Yeah. I'll try to do like a layer by layer CAD tutorial where I kind of walk through how this thing works in more detail. I think that's useful. Yeah, it uses a special potentiometer. Not really special, it's just more the mini type of potentiometer. It just works out better when it comes to like the body of the potentiometer. It fits better in this mounting bit, so that's why we're using a different potentiometer for the whammy bar, because it's just a better fit for the mechanism. So that's why I'm using the little mini potentiometer, not the blue one, the one with the black tip, and those are linked as well. All right, getting the JST connector wired up to it. Yeah, then walking through the assembly, snap fitting all the pieces together, and then mounting it to the bottom of the guitar, the bottom half of the guitar, using very similar M3 screws and hex nuts. Yeah. All right, next up is a bunch of wiring. So I think wire lengths are very useful, as it coming up with them was a bit of a trial and error when you first build it. I was trying to figure out what's the best wire length, so I walked through it, and always doing the second build works out well because then you know a really good idea of what your wire length should be. So that's throughout all of the different bits and components that have wires. I have wire links for all of them. That's very helpful. So wiring up an 8-way rotary switch, it's kind of nice using the 10-wire ribbon cable, because all of the wires are bundled together, and then at the ends I start splitting them and adding the connectors so that you can see all the various connections. Yeah. Okay. Same thing with the pots, very similar setup. With these two pots, I kind of left them together, bundled together, so that looks kind of nice. Also heat shrink tubing, so much heat shrink tubing. Panel switches, very similar setup. Permaproto. Yeah, I cut a piece off of the quarter size one. If you're gonna cut one, definitely do it in a well-ventilated area, preferably outside. If you are indoors, definitely wear a respirator and have some sort of dust collection, whether it's a shop vac or just a vacuum. That's what I did. I like mounted my shop vac right to the vise where I was clamping down the PCB and just cut it. So I had the pan of ice set up and my little rotary Dremel tool cutting it, and it was like right next to the vacuum, so it was sucking up all the dust, and that helped out. That worked really well. Yeah, this is going to help give us more ground voltage pins on the Grand Central, so that's why I did that. Wiring up the LIS3DH, just 4 wired connections, so I'm using the 4-wire JST connector for that. There we go. Wiring up the MX switches, using 12 of them here. The reason why we're using 12 MX switches is because we are kind of ran out of bed space on the 3D printer. So originally we were going to do 16 or so, but I couldn't fit that without splitting it in half, and I didn't really want to split it in half, so I sized it down to 12. It is a parametric model, so if folks want to make a really big one and have access to a big 3D printer, or want to glue 2 parts together, you can do that. I'm sure that's just doable. It's going to be more wiring though. So 12 of them is what we got. And wire lengths, yay. Yeah, so the way I have it set up is I have 3 4-pin JST connectors that will segment those into 4 switches each. Yeah, and the MX switches themselves just get kind of press fit into the cover of the neck cover, so they fit nicely, and they can still pop out as well, so they have a nice kind of tight fitting. When I installed them, I kind of made it so that they're all consistent. That way I can kind of share the grounds across all of the MX switches. So that's how I have them oriented. You can orient them in whatever way you want, but I think this orientation worked out well for the way I wired it. So more pictures. So I create a lot of little bits of wire. That way I can just use a small wire to connect, to share the ground across all of tie all the grounds together across all the MX switches. So that's why they're small, because the spacing between them is kind of short, right? So I set those up, and I have some photos. Yeah. Yeah, I'm trying to think of like some good tips. Just take your time, I would say. Don't rush through it. Use tweezers. Oh my goodness, this tweezer's helpful when you're wiring something in the close range. You want to be real careful because you're next to plastic that you could melt, whether it's the plastic from the MX switch or the plastic from the 3D print part. You want to be very careful when doing this. I think having a set of third helping hands is very, very helpful into holding things in place while you are soldering or soldering. Yeah, so third helping hands for the win. I also put some pieces of heat shrink tubing on those little bite marks so that they don't leave bite marks on your wires or your parts. That's another tip for you. Yeah, so I'm just walking through wiring all the things. And then this is kind of interesting. The way I have the keys wired, like the signals, the grounds are easy to do. They all have about the same wire length, but the actual signals for the switches, they're kind of staggered, I guess. They're kind of layered on top of each other, and hopefully these photos show you how you start with one, and then the next wire gets cut a little bit, and then the next wire gets even shortened a little bit more. That way, you kind of have this one continuous ribbon cable that goes down and really reduces the space needed for these wires. So that's why I have them wired up this way. And that's why I think it's really good to use the 10-wire ribbon cable, because it's already bundled together. It's nice and flat. It's flexible. It's silicone, so it has a little bit of a grippiness to it. So they kind of stay bundled together, which I think is useful. This was the hardest part of the, well, the most time-consuming part, I think, was this one, because you have 12 switches. We're like halfway through. Wiring up the NeoPixel feather. Just about any NeoPixel strip is gonna fit in the head, but I'm using the mini skinny style, which gives me a little bit more room. And they're the high density version, so they're like 144 pixels per meter. So there's about 35 pixels in the head of the guitar in my setup, the way I have it set up. So whether you have a low density or a medium density strip, it's all fine, it'll all fit. Just make sure you count up your pixels and that you put that in your code. Yeah. Definitely want to have an on-off switch for it as well. Otherwise, I'm not sure how you would turn it on and off. So I just walk through, wiring up the strip, wiring up the switch, and then wiring it into the feather, and then testing it out. 500 milliamp LiPo battery again. That seems to work out really well here. It's just 35 pixels. And for the demo code running on the Feather M4, I am just using the demo code that is inside the Uber NeoPixel guide, which is right here. So you can use this code if you just want to show that rainbow or different colors, like if you want a solid color. So you can kind of customize that as you want. I'm getting lost here with the tabs. All right, so that's setting up the feather stuff. All right, strip assembly, putting it inside the head of the guitar. I'm using some hot glue to keep it adhered to the inner walls. So that way it creates this nice diffusion effect. Now to install the feather into the neck, standoffs are just too big. So what I have is I have like one long screw, and then I put a hex nut on the bottom of it, acting as a very small, short standoff. So that's how I'm able to fit everything inside the neck of the guitar, and it's pretty tight in there. So that's why I have this little setup here where I'm using the hex nuts to elevate it just slightly away from the bottom of the surface. So and then using some other hex nuts to secure those nylon screws, so it's not going anywhere. The slide switch has a built-in holder, so that just gets inserted at an angle, and it's held in place like that through the geometry that's built into the neck of the guitar. I tend to use this holder for any project that uses the slide switch, so you'll see that a lot in a lot of our projects. And then we use JST connectors here so that we can actually attach it, and then I'm routing the cable, the 3-pin JST cable, through that little hole, so you still have access to disconnect it, and you have access to recharge the 500 milliamp LiPo battery or reprogram the feather. So you can just pop out the cover. We haven't put it on yet, but there you go. Yeah, so just keeping those wires nice and not too long. Okay, then after that, we're going to install the LIS2DH. The best spot we found for it was inside the neck, so it's right below the slide switch and the feather, so it all fits in there. Again, we're using the same method where we're putting some hex nuts to act as the standoff so that they're really, really low profile so that everything can fit inside the neck. Excellent. And then more hex nuts to secure those screws to the actual base of the guitar there, the neck of the guitar. And then a little bit of wiring management here. I actually have the battery cable going underneath the board. That way it's not creating this weird bend in the wire. So it's centered there. And I don't even have the battery glued or anything like that. It's just kind of in there. The ribbon cable tends to keep it nice and taut, so it's not moving around when I'm shaking it or anything. So that works out well. So yeah, all that fits in the neck of the guitar. It's crazy. Wiring up the M4, the Grand Central M4. Lots of connections are going to go in here, so lots of wires. Yeah. Yeah, the standoffs, I'm going to install those first before wiring anything. That way they're already on and I don't have to kind of work around them. So those are installed. I normally don't do this, but I used extra pieces of heat shrink tubing as labels. So I used like 1 or 2 note letters to really label the connections, because we're going to have to disconnect them from the various components in order to get everything mounted where they need to be. So by just putting a letter, you can really label them and segment them out. So I thought I'd just share the letters, like the letter X is for the accelerometer, and then A, B, and C are for the MX switches. The potentiometers, I have P1 and P2. W is for the whammy bar. Just numbers for the rotary switch, and S1 and S2 for the toggle switches. I thought this was really helpful. It actually did help me quite a bit, especially with a build with this many connections. You definitely want to have labels. And normally what I've done is like kind of use the sticker. I'll write on the sticker and then wrap it around. But using the heat shrink tubing worked out well. I got like a kit of these heat shrink tubings in various different colors and sizes, and that was really helpful because some of these, like the 4-wire JC connectors, have they need a bigger diameter. So having different sizes of heat shrink tubing is very useful.
I want to remind everybody, we got about 5 minutes left of shipping, so definitely take advantage and use coupon code FINALHOUR before we suspend shipping for a little bit.
Yeah.
So definitely speed up around over there.
I'm trying. All right, we're going to wire up the grounds and the voltages so we have more of them. That's from the Proto piece. And then I just walk through wiring everything. Very thorough.
Somebody was asking, did you use a lot of perf boards to connect everything?
No, I didn't use a lot of perf board. Just one piece of the Proto here.
Extend the grounds is what I said.
Yeah, to extend the grounds.
The Grand Central has, what was it, 20 GPIOs?
Oh, it's got like 30 or so. Check the website, check the product page, but yeah, it has a good amount. I think it says in the thing, but we're running out of time. Let me just walk through this real quick. Just follow the order if you're really building it, because it's pretty thorough. All the different things, all the different steps are in a nice chronological order, I feel. And then the final assembly, putting the neck in, putting the cover on. So closing this up is a little bit of not of a challenge, but you definitely want to layer the different connectors together in a way where they're flat and everything kind of finds its way, so that it's not stacked on top of each other, but kind of layered, and just it kind of all flows, all the cables and things. So with these wire lengths, you have enough to still be able to break it open and disconnect things or reconnect things. But yeah, the connectors are definitely helpful for this. So it's easy to get in there and see what everything is doing. It kind of looks like a mess, but there's order to the chaos. When it comes to the keycaps, not all the keycaps are going to fit. The more narrow shaped keys will fit because of the spacing, but you could change the spacing too if you want to do that. You could do that in the CAD and rework it. But yeah, I'm just using these blank keys. Yeah, the snap fits tend to work out really well. There's plenty of room for extra stuff, and yeah, putting on the knobs and things. That's really the final build of it. The usage page Liz put together has a nice demo. Well, we're in the back end, so we don't have the demo, but you can listen to it and check it out. And it just kind of let you know that it's using MIDI, and you can use different MIDI software for it. Whew, it's a bit of a build, but that's it. Check it out. I'll do some layer by layer stuff and walk through some more CAD things. I think there's a lot of interesting tips that we can pull out of those different mechanisms.
Yeah, apologies that we weren't able to get this out in time, but later today it should be released, at least the guide, and I posted links to all of the GitHub pages so you can get the code. Nice. And then the Thingiverse links so you can get all the STL, so you can get started with all that. The print time takes about...
yeah, I mean, it depends, but you're looking at a couple couple hours.
And then we have requests for people to go ahead and do another demo to close out the show. We will be back later tonight with show and tell, full hour of show and tell. So definitely stop by. Starts at 7 p.m. Eastern Standard Time tonight, and we'll be showing off a little bit more demos from the guitar and a lot of other projects that all the team members have been working on. A lot of the staff has been moved over to work on learning guides, so definitely be on the lookout for a lot more guides coming out during these crazy times. So let's go ahead and close out the show with a nice little demo there.
Stay safe, everybody. Wash your hands and stay indoors. We'll see you guys later tonight. Don't forget, show and tell is an hour long. We can't wait to see what everybody's working on, and we'll have more demos as well.
And don't worry, it doesn't have to be an electronics project. It could just be a arts and craft project you worked on with your kids while they're at home, or show off your workspace.
Yeah, I'd love to see that.
And right after that, we're gonna have another full hour of Ask an Engineer. Full hour with Lamar Phil to update us on all of the goings on, lots of news, and lots of new products are still being worked on. So definitely tune in for that.
Doggo.
And with
He's
that,
ready for a walk. And with that, folks, thank you so much for supporting Adafruit. We couldn't do it without you. So from the bottom of our hearts, thank you so much. And we wish you, where is it right here?
Right there.
Thank you. Yeah.
It's because of your guys' support that we're able to continue going on as things start to shut down. So definitely take advantage. We got about 2 more minutes before shipping is cut off. Don't forget to use coupon code Final Hour to get 10% off. And we will be back next week with more 3D Hangouts. There's a lot of stuff we weren't able to cover today since this project is so massive.
Too massive.
We will show off more of it next week. Show off some more features of the guitar, and some layer by layers coming out later this week as well. All right, Roof, say bye.
Oh.
Don't forget, everybody, wash your hands and make
a great day.
Great day.
Bye, folks.
See you later tonight, folks.